Hello everyone, my is Jason, the team leader.
And I'm Lester, the team's researcher.
And I'm Bryce, the main tech guy.
Now let's identify the problem statement. Since Borneo is an island surrounded by sea, every day loads of ships need to deliver parcels and packages to the residents residing on the island. Due to the high frequency of shipments, oil spill and water pollution are bound to happen, as what has happened in Igan River in August 2020.
Once oil is spilled into the sea, it is impossible to recover more than 20% of the oil even in ideal conditions. Burning oil as a result of the oil spill releases carbon dioxide into the atmosphere, contributing to the warming of our planet. This can cause adverse effects to our cities and communities. A lot of manpower is required to clear one oil spill. Hence, we propose an automated robot to clear the oil spill. Introducing our robot, Mr. Mustachio, to contribute to Sustainable Development Goal 11, sustainable cities and communities by cleaning up oil spills. This can also make up city municipals more efficient in disaster handling.
This robot is designed to clear oil spills in rivers or lakes with high efficiency. The microcontroller will use a micro front side torque. The fan motor on the torque helps to propel itself forward. We will our robot with a sensor to detect any stacker impact. When any stacker is detected, the robot will turn light with the help of a lever attached to a servo motor. It might sound simple, but it has more than 2 ways to get the code and robot release for free. Here the question gives to us, how does our robot clear the oil spills? Beyond the helmet attached in front to create the oil spillage.
Now, allow me to explain the coding of Mr. Mustachio. This line includes a servo library which allows an Arduino board to control RC Hobby servo motors. This line creates an object to refer to the specific motor. These lines allocate the variables and integer to be referred to the setup in loop program later on. This sets up the program at the beginning to process the data as input and output in the form of analog or digital. This sets out a loop program that runs over and over. This part ensures that the ultrasonic sensor is always emitting sound waves to detect any obstacles, while this part sets the automation for the servo to turn when the ultrasonic sensor detects an obstacle in front.
If you have noticed, yes, our robot is made entirely of used materials. The body is made from a plastic lunchbox we collected from our classmates. The 2 plastic bottles on the side was collected from the school canteen, and the helmet was collected from our classmate's mother who works as a barber. How is our robot not better than any other oil solutions?
We had a brainstorm session to sketch the board designs based on our previous readings. We even consulted the school's solar board teacher advisor to gain his insights on which is the best design. Finally, we settled down with catamaran design. The 2-house design gives them great stability on the water and also a lot more storage space compared to other vessels. Having 2 hulls makes them very stable on the water and also reduce the occurrences of inconsistent data collection for the sensors.
As you can see here, our robot has gone through a total of 4 generations of prototyping, where we did major revamps on each generation to correct the flaws. The first generation failed as it was unable to move at all. The second generation failed as it was only moving in circles, the weight was disproportionately placed. The third generation failed as it was barely moving as well, just like the first generation. For the fourth and current generation, we totally changed the base of the robot to decrease the weight. It can now move forward and change direction with ease. As you can see here, our robot can maneuver itself around in the water, and even turn when approaching obstacles. As you can see here, our robot picks up the oil and collects it well.
So what did we learn from this project? In my opinion, what was the most is our spirit of teamwork. We learned to encourage each other when our conflicting ideas and believing they have a pity on first, but we managed to settle in a serious manner. The most importantly, we realized that even though our robot may not be perfect and require many things, other team members are ready to by his side to assist and provide motivations. It is trust and faith help us to complete our robot. Therefore, us we are team Loading Metallica. Thank you.